Hi everyone, today we are talking about how to find the area of composite shapes. As a reminder, you do not need to write down everything that we'll cover in this video, but be sure to jot down important information and at least one example of each type of problem that we'll cover. Also remember that you can pause the video to jot down important notes, rewind to view information again, and fast forward if you think you got it. Just be careful, make sure you don't fast forward too much that you miss out on something important. So let's start off with a review of area. Area, as you should remember, is the amount of space inside a flat two-dimensional figure. So when we say two-dimensional and flat, we're talking about a shape that you can draw on a piece of paper. And it is measured by inches squared, centimeters squared, units squared, etc. So the units are now going to be squared because it's two dimensions. Instead of just a straight line, it is length and width, which is two dimensions. So both those have their own units, and they're going to be squared together. A composite shape is going to be a fancy name for an irregular shape. So composite has the word compose, meaning that this irregular shape is composed of or made up of regular shapes like triangles, squares, and rectangles. So it's kind of like if you were adding up different regular shapes. So here's an example of a composite shape. This right here is a composite shape because it is composed of or made out of one rectangle and a triangle just basically smushed together. So it made up a new shape. And since it's an irregular shape, we call it a composite shape because it's made up of two regular shapes. Before we move on, make sure that this is in your notebook. All right, so if we wanted to find the area of a composite shape, there's actually two different methods for calculating that area. The first method is to figure out what the regular shapes are, figure out their areas, and then add those two areas together. The second method is when you figure out what's the bigger shape that this shape can be taken from. And so you're going to subtract the regular shapes from one bigger regular shape. So we're going to use this example and show you two different methods to get the same answer. So we're going to start with method one. Method one is adding the regular shapes together. This composite shape is made out of one regular rectangle and one regular triangle. So we're going to figure out the areas for the rectangle and the triangle, and we're going to add them together. The 6 centimeters plus 8 centimeters is very important here that I added because if you notice, the 6 centimeters up here is for the length of the shorter side, and then they gave you 14 centimeters for the bottom right here, right? So then you kind of have to think to yourself, what does that 14 mean on the bottom? Well, the top part of this rectangle was 6 centimeters long. So I'm also assuming that the bottom part of this rectangle is 6 centimeters long. This whole thing had to add up to 14 centimeters, so that means that this part that sticks out, the part of the triangle, has to be 8 centimeters because that'll create that 14. 6 centimeters from the rectangle part that we saw up here, plus this extra 8 centimeters for the triangle would add up to that 14 centimeters. So that means the bottom and the top are not the same. Only from here to here are the same, the 6 centimeters. Okay? So again, back to the method, I'm trying to figure out the area of just the rectangle plus the area of just the triangle, and then I'm going to add them together. Area of a rectangle, as we remember, is length times width. So the 5 multiplied by the 14, or sorry, not the 14, by the 6. See how tricky that is? The 6 is the width of the rectangle. The 14 is the rectangle and the triangles together. So that's why for the area of the rectangle, I just have 5 centimeters times 6 centimeters. 5 here, 6 from here to here, and then we stop. The area of a triangle is length times width divided by 2, so I have to be careful on this one too. The length here is only 8, not the full 14, because 8 is from here to here. And then the height of it is just like the height for the rectangle. So I also have a height of 5. So I got the 5 for both shapes, and then the 8 is only from here to here because that's where the triangle begins, where this dotted line is. So that's how we got 5 and 8. And then after we multiply them together, we have to divide by 2. So 5 times 6 was for the rectangle, that's 30. 5 times 8 divided by 2, that's 40, divided by 2 is 20. That's for the triangle. So only the triangle is dividing by 2 because it's half of a rectangle. And then the area of the combined two regular shapes together is 30 centimeters squared plus 20 centimeters squared, which is 50 centimeters squared. Remember, we got the square because centimeters times centimeters is centimeters squared. This centimeters times centimeter is also centimeters squared. So there it is. That's method 1. You just figure out the regular shapes, their areas, and add them together. Make sure you rewind if you need to hear that one more time. And make sure this is in your notebook before we move on to method 2. All right, method 2 is the same shape as we had before, the 5 and the 6 and the 14. And remember that this piece jutting out here is the 8, so that's why I rewrote that. But if you notice now, the red marks are a little different, right? Because we're using the subtraction method. So instead of figuring out what the shape is made up of, you're figuring out how you could get the shape from subtracting it from some other shape. So I created, it doesn't actually exist, but I created a bigger rectangle. I made this whole thing into one huge rectangle. This is an extra piece here, this red, right? Because it doesn't actually exist. So I just created an imaginary bigger rectangle around the shape. If I create a bigger rectangle, then I have some extra space. So I will have to subtract that later. It's the area of an invisible triangle. Okay? So instead of making things up, we're subtracting it from something bigger to get what we want. Some people like this method better because they feel like it's easier to find certain shapes and they get less confused with the numbers. It really just depends on the problem and what your preferences are. You're gonna get the same answer though. So area of the bigger rectangle, we're gonna take that 5, the length, and now the width of this big rectangle is that full 14 centimeters because it's this whole thing here. So you're gonna have to use the 14. And then remember, this triangle piece right here doesn't actually exist, so we're going to have to subtract that out. This little triangle piece here has a height of 5 right here, because both sides should have 5. And then it's only this little piece for the base, and that's the extra from the 14. 14 minus 6 gives you that 8 jutting out. So this is 5 centimeters times 8 centimeters divided by 2. Okay? It's basically the other half of the other triangle, so it's the same numbers as before. Except this time we're subtracting it out from the bigger rectangle. So we also get 20 centimeters squared for the invisible triangle, because it's just the other half of the other one. And then for the bigger rectangle that doesn't actually exist, it's 5 centimeters times 14 centimeters, which is 70 centimeters squared. 70 minus 20 is 50 centimeters squared. So just a different way of getting the same answer. Okay, make sure you jot that down into your notebook. And then we're just going to do one more example on Khan Academy to show you how it's done. Okay, this example on Khan Academy has a slightly different looking shape. But you can also use both of our methods, either the adding or the subtracting. So go ahead and pause the video and try the method that you prefer. All right, so if I were to try the adding method, I would see that this composite shape is made out of a triangle, what looks like a square or rectangle, depending, and then another triangle. And I wonder if these two triangles are actually halves of each other. So that's something I want to think about. But before I do that, I want to make sure these numbers are correct. This right here is 2.5. This right here is also 2.5. This whole thing here is 7.5. So I need to subtract that from the 2.5. So I would get 5.0. That means this right here is just 2.5. And then what's left over on both sides together have to add up to 5.0. And I can also assume that they're both going to be evenly split up because of these two lines here. These two lines mean that they're equal. They're saying, hey, this line is equal to this line. Sometimes you'll see one mark or you'll see two marks. As long as they're matching marks, then you know that they're the same. Okay, so it looks like it's 2.5 here and another 2.5 on that side. So there's 3 2.5s to add up to that 7.5 total. So I can get my area as my area of my square plus my area of my triangle plus another area of the other triangle. And it looks like these two triangles actually are the same because they have 2.5 on one edge and then another 2.5 on the other. They share the same numbers. So it's actually the same as this square plus these two triangles together. And let me draw that more so it looks like it's together. Okay. And then this square has, let's see, use a different color, 2.5 here and 2.5 here. And then these two also have 2.5. So it's really just like two of the same squares added together, which makes our life pretty easy. I want to put these two triangles together because instead of doing divide by 2 for both of them, I'll just put them together and then I won't have to do any dividing by 2's. That's going to avoid more mistakes. So this is 2.5. We don't have any units, so we're just going to say U for units, times another 2.5. And then we are basically doing the same thing for the other one. So I could just write that over again. With my lack of space. Okay. So 2.5 times 2.5. I have to put into my calculator. That's 6.25 units squared. I'm going to basically add it to another 6.25 units squared. So it's basically just 6.25 times 2. So that's 12.5 units squared. So that's the adding method. You could have also chosen to use the subtracting method. So with that, you would probably create a bigger rectangle, and then you would subtract these triangles out, which again are going to be identical to each other. So it's just like taking a big rectangle and subtracting out a smaller square. Okay, so we're going to do that one as well in case you chose that method at home. Let's see, the bigger rectangle will have 2.5 by, oh, now we're going to use a 7.5 because the whole length is going to be 7.5. And then we're going to subtract out these two guys. And so they're 2.5 by 2.5. Okay, so if we were to do the math there, it would be 2.5 units times 7.5 units minus, again, those two triangles create one square, so it's just those two multiplied by each other. No dividing or anything. We're trying to save ourselves some work. Times 2.5 units. And then that's going to equal to, let's see, 2.5 times 7.5. The bigger rectangle is 18.75 units squared, because 2 units, minus 2.5 times 2.5, we already did that up there, 6.25 units squared. So then I actually just have to subtract that, and I get the answer 12.5 units squared. So either method will work. They seem to have the same number of steps even, so there's really no wrong answer. I've had people do both methods just to double check their work and make sure that their answers are the same on a test. You might want to do that if you have extra time, right? Just to double check. Okay. So that's the lesson on how to find area of composite shapes. Let me know if you have any questions as you work on these problems, and I'll see you in class.